Okay, so we're going to take a look at stretching and shrinking a parent graph. And we're going to start with the absolute value function. So let's take a look at putting the absolute value function on our graph. Paper here. There's the absolute value. Now I'm going to go ahead and use, I want you to understand the reasoning and the why of this stretching and shrinking, and why it actually becomes we call it a vertical stretch and shrink that we're talking about this time. Vertical. Let's take a look at the parent graph and the values that I've chosen. Let's say a -2, -1, 0, 1, and 2, and of course that becomes a 2, 1, 0, 1, and 2. So I put in an X, I get out a Y. Now let's see what happens when I make an adjustment. Right? Let's take a look at this. What I'm going to do is I'm going to take, let's just go ahead and make another table, and I want you to notice what happens. If I still choose to put in the same values, what's going to happen here is I'm going to get a 2, but I'm going to have a -2 sitting outside. Excuse me, not a -2. I don't know why I saw that. Well, that's what I was looking at, is the input was -2. If I put a 2 times the absolute value of -2, which is 2, I'm going to get a 4. On this one right here, I've got a 2 times the 1, I'm going to get a 2. This one's going to be a 2 times 0, which is still 0. This one's going to be a 2 times the 1, and that's a 2, and 2 times 2, which is 4. So you can see what has happened. Let's take a look. The Y value has been multiplied by 2. Obviously, right? That's what we did. This is a multiplication by 2. Well, let's look at the original. There's the original value. There's the adjusted value for each input. So what is happening is this, we call this a vertical stretch by a factor of 2. Why? Because we multiplied by 2. So let's go ahead and put this one on. And I'm going to highlight it for you once I put it on. So in other words, I've started at 0, 0. But instead of over 1 up 1, I'm going to go over 1 up 2. Instead of over 2 up 4, instead of over 2 up 2, I'm going to go over 2 up 4. And there's the logic. I'm multiplying every Y, that's right. I'm multiplying every Y value by 2. And there it is. Now I'm going to go the other way. So instead of a slope of 1, the slope is 2. Right? Because these are straight lines on either side. So now let's go ahead and highlight that. There's my adjusted times 2. So it's a vertical stretch by a factor of 2. Vertical stretch by a factor of 2. Let's take a look at this next one. Okay, I'm going to go ahead with green on this one. So I'm going to call this one my green one. And let's take a look at what happens to the values. Well, you already can tell, right? You know you're going to input the same thing. And what's going to happen to the Y value? The output is actually going to be half as much as it originally was. So that's going to be a half, that's going to be that, there's going to be a half, and that's going to be 1. Well, it makes sense, doesn't it? So let's go ahead and take a look at these. These values here, compare them to the original, and they're half as much. Well, they're half as much, and that's because we have half the value there. So let's go ahead, and that's going to be called a horizontal shrink for obvious reasons. So instead, we're going to go over 0, 0, over 1 up. Instead of 1, we're going to go up a half, over 2 up 1, and there it is right there. Okay. Vertical, like I said, a vertical shrink by a factor of a half. It's half as tall. Now, when I say tall, I don't mean how high, the height that it actually reaches. It's going to reach infinity in the Y direction. I'm just saying that for every value that used to be a 1 is now at a half, and it's going to take it longer to get there in a sense, in theory. So let me go ahead and do this one. Highlight this one with green. And there you go. Vertical stretching and shrinking. Thanks for watching.